All right, this video will go over the back side of your study guide, and that is problems 10 through 16. You need your study guide, obviously, and something to mark it up with. It might be a pen or pencil, but you want to kind of keep track of how you did. If you made mistakes, you want to fix them. If you left something blank because you weren't sure how to do it, then you want to fill these in as we're going. Again, this is a video, so you can pause when needed and see how your answer compares. So feel free to pause whenever needed. All right, number 10, the 7th grade math classes are going on a field trip. The field trip will cost $6 per student. First, write an expression to find the cost of the field trip for S students. Then find the total cost if 194 students go on the trip. So first things first, let's write the expression here. We know that the cost is $6 per child, and we know that we have a variable representing the students that are going. So the expression would look something like this: $6 times however many students that is. And I even defined my variable, where S represents the number of 7th grade students. So the expression that we're solving is this one. Now, in the second part, they say then find the cost if 194 students go on the trip. So we take our expression and now we can substitute a value for S. So really we get 6 times 194. And if we multiply that through, we would get $1,164. Now you can use a calculator here, but again, you should show what you did to get your answer. In number 11, right here, this is the properties section. This is a challenging one. You need to make sure you're paying special attention to a lot of this because they could ask different questions on the test. They could switch things up. So what I put down here was a reminder of some of the basic number properties. The commutative property, that's where you can switch your values. It doesn't affect your answer. It works for addition and multiplication. The associative property is where you can kind of associate different numbers together and still get the same answer. That also works for addition and multiplication. The identity property is when a number doesn't lose its identity, like if you add 0 to something or if you multiply something by 1, you still get the same answer. Okay, that's the identity property. And you also have the distributive property, which is a big one that's going to play in here very soon. So this is a reminder of some basic properties. Now, we've known these for years. You've known these for years. This is not new information. We're just giving names to things that we already know. So let's go to number 11, simplify the expression. Well, simplify means here, combine like terms. Bring the things together that you can bring together. Now, I put a little box around this part first because when you see this, you should think I need to distribute first. I need to multiply what's outside by both of the terms inside. So over here, I did that. I did 3 times x, and I get 3x. I did 3 times 2, and I got 6. So this is really equivalent to 3x plus 6, just this part right here. So if I rewrite this whole problem now with that in there, that's what it looks like. And I'm going to highlight really this part right here. I just found this as its equivalent value by distributing. Now I can do a lot of things. I can combine all of the x's. Again, that's like 1x plus 3x plus 3x plus 2x. If I combine those, well, 1 and 3 is 4, plus another 3x is 7x, plus 2x is 9x. So those combine to 9x. But I also have here some constants. I have this 6 and I have this 3. And if I combine those together, I get 9. So I'm left with this simplified expression, 9x plus 9. And there was a lot going on here. I had to distribute first, I had to combine terms, and I can't go any further than this. Sometimes students think, well, I can add these and get 18x. And they just broke the rules when they did that because these are unlike terms. I cannot add a constant with something that's different from it. And this has a variable here, so I can't combine those. And I can't go any further because I don't know x's value. In number 12, write two equivalent expressions that illustrate the associative property of multiplication. Well, the associative property of multiplication, if you remember what that is, that's where we want to multiply. So we're multiplying three quantities, but we're grouping these two together here and then timesing it by the third one. But in this one, we're grouping the last two and multiplying it by the first one. So if I substitute some numbers here, this is kind of what's going on. And some examples of that would be this. Okay, like look at what's in yellow. 2 times 3, that would be 6 times 4. That's 24. But if I group these two, well, that's 12. 2 times 12 is also 24. So this shows the associative property of multiplication because I have associated these two numbers here and a different two numbers there, but I still get the same answer. And they want the associative property of multiplication. I should not be adding, I should not be subtracting or dividing because that wouldn't even work. But another example would be just me using 1, 3, and 5. If I group the 1 and the 3 together, I would get 3 times 5. If I group these together, I would get 1 times 15. Both of those have the same resulting answer. So I wanted to just show two things that are equivalent using this property. Now, on a test, they could ask you really about any of these. So you want to be prepared to explain any of those properties. They could say the commutative property of addition, or they could say the distributive property. So you want to just make sure you know your properties because you never know what's going to come up. Number 13, it says determine whether 20 minus 10, I should say the difference of 20 and 10 minus 5 is the same as 20 minus the difference of 10 and 5. So we got to prove this one, okay? And if it's right, we would say it's true, and if it's not right, we would say it's false. Well, if I solve this left side of the equal sign, I really would get 10 minus 5, which is 5. If I solve the right side over here, I'd get 20 minus 5. And 20 minus 5, that's not doing what I want to do. 20 minus 5 is 15. So I get different answers here. So it's false. And the reason it's false is because I end up in different spots. This kind of looks like the associative property. I'm grouping these two together, I'm grouping these two together, and I really have the same three numbers. But the associative property doesn't work with subtraction. Okay, it only works for addition and multiplication. So this is false, and I want to explain that with words. Okay, I can say something like the associative property only works for addition and multiplication, not subtraction. Or I can say, I know it's false because I get different answers when I solve both sides of the equal sign. All right. The next problem, 14, another true or false. Addition of whole numbers is commutative. Support your answer. We got to figure out if this statement is true or if it's false. So remember, the commutative property is one where if I add two numbers together, the order doesn't matter. The root word of commutative is commute, and that means to change positions. So think of this like 3 plus 4 and 4 plus 3. Do I get the same answer? Well, yeah, I do. So I want to prove that, and I just want to show it. Yeah, I mean, an A plus B is the same as B plus A, because the commutative property, it works for addition. So this is true. It also works for multiplication. Okay, if you think about that, 3 times 4 is the same as 4 times 3. That's 12 and 12. So it works for some operations, but it doesn't work for subtraction. It doesn't work for division. So again, this is a problem that you need to be prepared for how it could look different on a test. Maybe they say addition of whole numbers is, subtraction of whole numbers is commutative. And if they said that, that'd be false because I can't switch my numbers with subtraction and still get the same answer. So as it's worded right here, it is true. Number 15, a friend rewrote the expression 2 times the sum of x and 10 as 2x plus 20. Did your friend distribute correctly? Support your answer. Well, I want to remind you, this is distribution. When you see a number outside and two terms inside, multiply. what's outside by both of the things inside. And if I did that, I would get 2x plus 2 times 10. Now, this is just going to be 2x. This will be 20. And that is true. Your friend did the good math. Okay, we're proud of them. Well done, friend. So we want to basically show that or explain that. But yeah, these are equivalent. This right here is equivalent to that because they did distribute correctly. Number 16, we have to figure out if each of the expressions below is equivalent to 12 times the sum of t and 4, 12t plus 4, or neither. So we have 3 options. I want to remind you of something first, the distributive property. When we see this right here, that's an indicator that we can distribute. Think of this as the 12, think of this as the t, and this is the 4. So the first thing we should do is we should distribute. Okay, 12 times t, well, that's 12t. 12 times 4, well, that's 48. Now, I did that because I want to be able to think of this as an equivalent value to see, because I have to eventually figure out, are all of these, is it this one or neither? And so if I can distribute here and realize that that's really 12t plus 48, that'll help me out with some of these down here. Now, this one I don't have to do anything with because I don't need to distribute. And there's nothing for me to combine and there's nothing for me to really do. So now I want to start working through these. And if I look at this first one, t plus 12t, well, if I combine those, I get 13t, adding 4. Well, this is different than this. It's not that because this is 12t plus 4. So this first one is a neither. And the second one, if I combine the two 6t's, 6t and 6t is 12t, well, that 4 stays separate because it's an unlike term. Now I see this differently and I say, you know what, that's not this one, but it is that middle column. So I'm going to put a check mark there. 12t plus 48, well, I don't have to really do anything with this one because I already know that this is the same as 12t plus 48. So those are equivalent right there, first column. Here I should distribute. Again, I have something outside and 2 terms inside. So 2 times 6t is 12t. 2 times 2 is 4. And that right there is this one. So a middle column again. And this bottom one, I just need to combine my terms because I can add these constants, 40 and 4 and 4, that's 48. And this 12t needs to stay separate. So 12t plus 48. There's that one again. So it's the first column. Do you see how important distribution is? If I don't distribute this, then I'm doing a lot of difficult work over here to try to figure out, are these the same? So distribute when you see this. Distribute when you see this. All right, that brings to a close this part right here. Thank you very much.